Let's discuss this question next. What does the question say? If A transpose is equal to 3, 4, minus 1, 2, 0, 1 and B is equal to this matrix, okay, then verify that. Okay, we are supposed to verify the properties of transpose for these matrices. Let's try to do that. And there are two parts. Let's try to solve them one by one. We have to verify that these properties are true for these matrices as well. Okay, let's begin with the first part. How do we approach the first part? For the first part, what I need is, on the LHS I have A plus B and then I take the transpose. Now am I given A over here? No, I am given A transpose over here, but I am given B. So first let me find A using this A transpose. Given A transpose is equal to this matrix 3, 4, minus 1, 2, 0, 1 implies matrix A would be equal to what? Matrix A is the transpose of this matrix, which will be the first row becomes the first column, the second row becomes the second column, the third row becomes the third column over here, right? Given A prime equals to this, we get A equal to this, and B is already known. B is already known to us. B is minus 1, 2, 1, 1, 2, 3. This is given. So therefore, I can easily find A plus B. A plus B will be equal to the sum of these two. 3 minus 1, which is 2. Minus 1 plus 2, which is 1. 0 plus 1, which is 1. 4 plus 1, which is 5. 2 plus 2, which is 4. And 1 plus 3, which is 4. This is matrix A plus B. This is sum of matrices A and B. And from here, I can get A plus B transpose very easily. What will A plus B transpose look like? A plus B transpose would be the transpose of this matrix over here. This is 2, 1, 1. The first row becomes the first column. And 5, 4, 4. This second row becomes the second column. This is my matrix A plus B whole transpose, as you can clearly observe. Let us call this equation number 1. Next, let us talk about the terms in the RHS. Now, what do we have in the RHS is A prime and B prime, okay, and A transpose, that is already given to us. Let's find B transpose first of all. Okay, so for the RHS, let's find B transpose. Since B is given, what is B? Minus 1, 1, 2, 2, 1, 3. This is given. Implies B transpose is equal to minus 1, 2, 1, the first row becomes the first column and the second row becomes the third column. B transpose equal to this. Also, comma A transpose is equal to what? A transpose is given. This is 3 minus 1, 0, 4, 2, 1 and this is given. Okay. Therefore, A transpose plus B transpose is equal to what? This can be found easily, yes. A transpose plus B transpose can be found by adding the corresponding elements. Let's do it. 3 minus 1, which is 2, 4 and 1, which is 5, minus 1 and 2, the sum is 1, 2 and 2, the sum is 4, 0, 1, the sum is 1, 1, 3, the sum is 4. This is what I obtain, and let's call this statement 2. Now, observe the matrices obtained at the end of 1 and at the end of 2. This is 2, 5, 1, 4, 1, 4, 2, 5, 1, 4, 1, 4. The two matrices are exactly same. And this is what we started with. We wanted to prove this particular result, that is A plus B whole transpose is equal to A transpose plus B transpose, which is true for these two given matrices here. Right? So from 1 and 2, A plus B whole transpose is equal to A transpose plus B transpose. This is hence verified. This is completely verified, right? And that is all for this part over here. This is the first part of this question. Next, we'll take a look at the second part. Now, what does second part say? It says that A minus B transpose, whole transpose, should be equal to A transpose minus B transpose. So, once again, we'll begin with finding A first. Since A transpose is given, A is not given, we'll find A using this A transpose. Right. So, since for the second part, since A transpose equals, this is 3 minus 1, 0, 4, 2, 1, comma then then since A transpose is already there, then A, the matrix A will be equal to what? The matrix A can be easily obtained. This is 3 minus 1 0. The first column becomes the first row, the second column becomes the second row. This is matrix A, okay? And matrix B is already given. Matrix B is already known to us. This is minus 1 2 1 1 2 3. This is already given to us. This matrix is already given. Okay. Can we find A minus B very easily? Yes. Therefore, A minus B is equal to what? A minus B will be obtained by subtracting this and this. Now, 3 minus of minus 1, what will that be? 3 minus of minus 1 becomes 3 plus 1, which is 4. Minus 1 minus 2 will become minus 3. 0 minus 1 will become minus 1. This is what you will be getting. What next? 4 minus 1 is equal to 3. 2 minus 2 is 0. 1 minus 3 is minus 2, and that is what I get over here. This is the matrix A minus B. Now, using this matrix A minus B, can we further find A minus B transpose, whole transpose? Yes, we can easily find that. This implies A minus B whole transpose is equal to the transpose of this matrix. What is that? The first row, 4 minus 3 minus 1 becomes the first column. The second row, 3 0 minus 2 becomes the second column. And let's call this statement 1. Let us call this statement 1, right? This is A minus B whole transpose. What about the RHS? For the RHS, we want A prime and B prime. That is A transpose and B transpose. A transpose is already given. And using B, can I find B transpose? Yes. Let's try to find B transpose. Since B, matrix B is given to us, what is that? Minus 1, 2, 1, 1, 2, 3. This is given. Then B transpose is equal to what? This is minus 1, 2, 1, 1, 2, 3. This is the matrix B transpose, right? Since B is equal to this matrix and B transpose, therefore would be equal to this matrix. Can we find A transpose minus B transpose very easily? Yes, that's what is required. So therefore, A transpose minus B transpose is equal to what? A transpose is already known, given. This is 3, 4, minus 1, 2, 0, 1. This is the matrix over here. And what is B transpose? B transpose has already been found. Let's use that. 2, 2, 1, 3. This is what I get. And this is further equal to, this gives me A transpose minus B transpose is equal to this matrix over here. 3 minus minus 1 will become 4. 4 minus 1 will become 3. Minus 1 minus 2 will become minus 3. 2 minus 2 is 0, 0 minus 1 is minus 1, and 1 minus 3 is minus 2. This is what I obtained. This is second statement. Now let's take a look at the matrices obtained at the end of first and the end of second. What do we have? This is 4, 3, minus 3, 0, and minus 1, minus 2. These are exactly same, and yes, from 1 and 2, we can say that this property has been verified. What's the property? A minus B whole transpose is equal to A transpose minus B transpose. Mind you, we are simply verifying this property. It's not the proof of this property. This is a simple verification of this property over here, right? So we have verified these two properties for this given question over here. Let me get aside so that you can take a look at the complete solution, right? And that is all for this question over here.